just about 2 more examples to go for the quadratic-like equation here. So example number 9. And let's say we want to solve for x. Okay? And the equation here we have is x minus 5 all squared minus 4, and then x minus 5 again, and then equals 21. Okay? So before I proceed with anything, let's say we just simply subtract the 21 from both sides. Okay? X minus 5 all squared minus 4 x minus 5 minus 21 equals 0. So now what I need you to see here in this problem, it's not really that much, but then what I want you to see is, once again, we have that repeat right here. X minus 5 is my repeat. Okay, I have a repeat of x minus 5. That's the first thing I notice. And then for the first x minus 5, the quantity is being squared. For the second x minus 5, the quantity is being left with first power, with power 1. So here I do have quadratic-like behavior. Square, first power, power 2, halfway down, and then no power. So now my substitution here is t equals x minus 5. Okay, that's the substitution we need to make here. So my equation here turns out to be t squared minus 4t minus 21. Once again, because anywhere I'm seeing x minus 5, the part that I kind of underline with the squiggling line right here. So we replaced that quantity by a t. So t equals x minus 5 is my substitution point. So equals 0. Okay. So now what I can do here, once again, here I'm obviously back to a quadratic equation in terms of t. So solving for t, okay, I can factor that. T and t. So minus 7 plus 3. So I found for myself t plus 3 equals 0 and t minus 7 equals 0. And so that means one t value is x equals t equals negative 3, and the other t is t equals 7. But now once again, keep in mind, the answer for t is not our final answer we're looking for. The answer for x is what we're looking for. So if you look back at the substitution point, t equals x minus 5, I can see that x minus 5 can be set equals to negative 3, and at the same time x minus 5 can be set equals to 7. So at this point, solving for x is quite easy now. Adding 5 to both sides. Adding 5 to both sides. And we have x equals 2. That's one of them. And x equals 12. That's the other solutions. And that's how you solve another quadratic-like equation. Now notice, if you ask yourself the question, in this equation, can you solve that in other way? Yes, you can. You can just simply FOIL the x squared, FOIL the x minus 5 all squared, and then FOIL, distribute that negative 4 with the term and rearrange the term here and turn that into a new quadratic. You can just solve that as a quadratic again. But in this case here, in this problem, we do want to solve it specifically as a quadratic-like equation. So one last example to show you how you can look at these quadratic-like equation here. Example 10. We want to solve for x once again. What I have here, x plus 3 all squared plus 7 times x plus 3 minus 18 equals 0. Okay, so now with my equation here, it's obviously we got a square, the exact repeats of the quantity, no square, and then there's no power. So here it's just, I'm so ready for my substitutions. I'm going to go straight into t equals x plus 3. Okay, and in this equation I don't even have to worry about rearranging the terms because it's already leaving a 0 on the right hand side. So we're good to go. So now, here's my substitution point. So now, that means when I look back into my equations, anywhere I'm seeing an x plus 3, I'm going to replace that by a t. So here I have the first term becomes t squared, second term is plus 7t, the last term is minus 18 equals 0. And that's how we are turn that our first equation into a quadratic equation in terms of t. And then solving for t, once again, what I need to do, factoring is pretty much my only access so far in any of these problems. I need a t here, plus 9 minus 2. Okay, so now immediately that's give me t plus 9 equals 0, and t minus 2 equals 0, and that produces t equals negative 9, and t equals positive 2. Okay, and once again, we're not done with the t. We're not done solving because here we only found an answer for t. I need to go all the way back, and let's say t, at the substitution point, t equals x plus 3. So now I can equate x plus 3 with negative 9, and then x plus 3, I can set x plus 3 equals 2 as well. So now I'm producing two other equations. Now I can solve by subtracting 3 from both sides. And that gives me x equals negative 12 for one of them. And subtracting 3 from both sides, x equals negative 1 on the other hand. And that's how I can solve for it, for my equation using substitution method. I mean using quadratic-like equation methods.